If you want to learn how pointers work in C, stick around. We're doing that next on low-level learning. In this tutorial, we're going to be talking about pointers, and in order to understand pointers, we first need to understand program memory. So I've made some memory up here, and the columns from left to right are the address of the memory, the value of the memory, and the name of the memory, or the variable name as tracked by the compiler, right? And what we're going to do is we're going to walk through some declarations in C and see how they affect program memory to kind of get a visual of what's going on when we make pointers. So let's look at this first one, right? This first one is really straightforward. Integer x equals 4. What does this do? It says that I'm creating an integer whose name is x, and it's equal to the value 4. So what the compiler will go ahead and do is at some address on the stack, which this is the address here, we'll call it 0004. It will make an address named x, and it will put the value 4 there. So now the compiler knows whenever we're talking about x, the name, we're talking about the value that lives at this address, at address 0004, right? Pretty straightforward. That's basic variable declarations in C. Let's move on to our first pointer declaration. So what this is saying here is that I declare an integer pointer, right? That's what this part means, an int pointer. An integer pointer whose name is my pointer, and its value is equal to the address. That's what the ampersand does. It's the address of something, the address of x. So if we actually go into our table and we look at my pointer, as it's now called, my pointer's value is the address of x. Those are the same. So whenever we talk about my pointer in the compiler again, the compiler knows we're talking about the thing that lives at this address, and what lives at this address is this value, and this value just also happens to be the address of x. Pointers are just values that happen to be addresses. It's really not that complicated. So to kind of solidify that concept, let's take it up to hard mode, and we'll do one more example, make it a little more complicated. All right, let's step it up one more notch, okay? In this example, I have an integer pointer, or a double pointer, and all that means is it's a pointer to an integer pointer, right? We're doing some pointerception here, but it's not that bad. So an integer pointer whose name is my d pointer, and its value is equal to the address of my pointer. So take a second, put your thinking cap on, pause the video. I want you to think about what the value of my d pointer is going to resolve to. All right, take a second, pause. All right, the value ends up being OX7FFF0008, right? Because I said my d pointer's value is the address of my pointer. So it's this value. So now we have this link, this kind of list getting created here where this points to this and this points to this, right? Excuse my art. Okay, anyway. So now that we've kind of, in a very abstract concept, figured out how pointers work in RAM, let's go into the C, write a little bit of code, and figure out how pointers actually behave when we create them. So on the left here, we have my editor, right? Trusty old Sublime. And on the right, we have my command line where we can compile and execute our code. And we're just gonna mess around with those declarations which we talked about before. So the first, int x equals 4. Very basic C statement. We're creating a variable on the stack. His name is x, he's an integer type, and his value is 4. Cool. So let's write our first pointer. And what the pointer is going to say is my int pointer, his name is my pointer, and his value is equal to the address of x. And all we're saying is that we've created a pointer who points to x, right? Really straightforward. And we can actually explore the different values we've created here by writing a printf statement. And we're going to print x equals %d for decimal, and my pointer equals %p for pointer. Throw in your new line and add your format strings. So x and my pointer. Don't forget your new line, or don't forget your semicolon rather, and write return 0. GCC, compile your code, get it to run, all that good stuff, and then run it. And what actually happens is pretty similar to my drawing, right? X is 4, which is the value that we set it to, and then my pointer is equal to the value of a pointer is an address, right? And this is actually the address of X, right? Not that complicated. The question then becomes, how do we explore what lives at my pointer? That is called a dereference, and we'll show you how to do that right now. So the thing pointed to by my pointer is equal to, it should be a decimal type, right? Because it should be X. And then we're going to do what's called a dereference. So when you're talking about pointers outside of their declaration, right? So any other use of them, to get the value that they point to, you type a star. That's called a dereference. We're going to dereference my pointer. This statement should say 4 because we're just saying, what is the thing pointed to by my pointer? It should be X, 4. Boom. The thing pointed to by my pointer is 4. Really straightforward. Let's take it up one more notch. I'm never going to leave it easy on you guys, right? Int pointer. My D pointer is equal to the address of my pointer. What am I saying here? I'm saying I have a pointer to an integer pointer. His name is my D pointer, and his value is the address of my pointer. Let's do the same thing we did before. We're going to explore what it is. It should be a pointer. And we're going to say, well, let's leave it at that for right now. Let's keep it easy. Okay, good. So our sanity check has passed. It is still an address. It's still just another address on the stack. This is actually the address of my pointer, right? What is the thing pointed to by my D pointer? This should be what? It should be my pointer, right? It's the thing that my D pointer points to, which is just another int pointer. Good. So we've done our first layer of dereference, and then the second layer, if we double dereference this, what do you guys think is going to pop out? The answer is, drum roll please, it is X, right? Because this pointed to this, and then this pointed to X. And once we double dereferenced it, we were able to get the end value in our list, per se. Anyway, guys, I hope that was enlightening. I hope you learned something. If you did, drop a like, leave a comment, hit the subscribe button. I put out content like this every week. Anyway, keep on learning and enjoy the rest of your night. Thanks, guys. Bye-bye.